Hi everyone, let's solve today's daily challenge, that is remove nth node from end of the list. So you are given head of a linked list and you need to remove the nth node from the end of the list and return its head, right? Okay, so let's first see what the question is. Question is pretty straightforward. All you have to do is you are given an n. See, this is your linked list. Let's call it LL. Linked list is given and n is given, right? So n in this case is 2, right? N is 2. That means the node, the second last node, right? So you have to remove the nth node from the last. So it's going to be 1, 2. This node you have to remove and you have to return the linked list. Right? So this is what you have to return. You have to basically remove this link and you have to point it here. Okay. Now, because this is a linked list, right? Obviously, you cannot do a backward reversal and get the nth node from the back. What you will have to do, you will have to iterate from like here. First, calculate the length, and then calculate what is the nth node, right? So you'll calculate, let's say, length of the linked list, then n the node that you have to remove from the last plus one. So this will return you the node from the starting, right? That you have to remove, right? So in this case, length is what, 5. So 5 minus n, 2 plus 1, what is it? It's 4, right? If it's 4, that means 1, 2, 3, 4. So it is the fourth node that you have to remove from the starting, right? So you are given from nth and then like that. So first you will have to do like iterate like this, then again iterate and go up to this particular node, and then remove the node. All right, but can we do a better approach? Can we do it smartly, right? See, this approach is very naive kind of an approach. Like, everyone can come up with this approach, it's so common. But in the interview you have to showcase that you are also although the space and time counting, that they won't be having much of a difference, but still you can show them that you can handle problems smartly, right? So for that, how can you handle this problem smartly? That is the question, right? So you must have already heard, if you have studied linked list, you know how two pointers are very very important in linked list, right? So here also, what we're going to do is we're going to take two pointers, first and second. Both will be initialized to head, right? Initially, they both are at head. Okay, let me draw the linked list again. This is your linked list, and I'm saying that both F and S are pointing at the head node. Now, what I'll do is I will take this S to the nth node from the starting, right? So from the starting, what is the nth node? 1, 2. So this is the nth node, right? So I will do while n minus minus, and from the starting, right? From this particular head node, I will find out the second node. Oh, sorry, the nth node from the starting. Now what I will do is I will move these pointers by one node ahead, until the second pointer becomes null. Okay, so let's do that. Let me take another pen. Let's take green, right? So initially F is here, and we had already taken S here. S is on the nth node from the starting of the linked list. Then what we'll do, move these pointers one by one. Move these pointers one by one. So now F is standing at the second node, S is standing at the fourth, this node, right? Then so right now S is not null, right? If S is not null, what you have to do, you have to keep iterating. So F will be moved here, S will be moved here. All right, then again S is not null, keep moving forward, S will now become null, F will be standing at this particular node. Now you can see, after S becomes null, right? After S becomes null, F is standing where? F is standing at the nth node from the last, right? So this is how we handle this question easily, right? So we didn't have to do a whole traversal, find the length, and then again do a traversal. Rather, we have simply done this particular traversal, right? And first, what we do, we took S to the nth node from the starting, and then we kept iterating until this second node didn't become null, right? As soon as it becomes null, your first pointer will be standing at the nth node from the last. So you know what is the nth node from the last? So it is stored inside the first. Now, because you have to remove this f node, what you can do is, while iterating, keep a track of a previous value. Okay, keep a track of a previous value. So previous is f, and then do f is equal to f next and move ahead, right? So in that case, prep will contain what? Prep will contain this 3, right? This particular node. So now I know what is the previous of f. So I have to remove this. So all I have to do is I have to make this next pointer, right? That is previous of next, correct? Previous of next pointer must point to what? The next node of f, right? So f of next. So you broke this pointer and you pointed it to this. Now you can see that this particular node has been removed from the linked list, right? So this is how you have to solve this question. Now there will be edge case or corner case where your nth node is actually the first node from the starting, right? If that's the case, then you obviously cannot do it. If you're, let's take this case, let's say we have 1 and 2 and n is 2. That means 1 2, this is your head node, correct? So this logic will not work because you don't have a head. Either you can use a dummy node, but what we can do is, in this situation, get the length of the linked list, and also while moving like this, right? While iterating here also using f and s, what we can do is keep a track of an m pointer, oh sorry, m integer, right? So inside of n, we'll first calculate the length of the linked list. So here in this case, it's for this case it's 2, and then you can take this as len, and then take this m, right? While iterating for this, right? You're moving f and s, right? So take this m, and if your len becomes equal to m, that means that means you have to remove the head node, right? So this is the corner condition or an edge case that you have to keep in your head, right? So after you get this corner case, simply check length is equal m. If it is, simply do head is equal to head of next. So this head node will automatically be removed, and this will now become your head, and you have to simply return head node from here, right? So I hope now you have understood the logic. Again, big O of n is going to be its time complexity, and the space complexity is going to be constant, right? Because you are not storing these nodes in any data structure, etc. All right, now let us go ahead and quickly see the code for this, right? So we are taking 3 nodes, first, second, and previous. So first will be at head, second is also at head, but what you have to do is you have to take second to the nth node from the starting. So here we are also checking if head of next is, there is only one node, right? If there is only one node, then obviously if you have to delete a node, correct? So that means you will be having nothing. So if there is only one node inside of the linked list, if you remove that node, you will be having nothing, so you have to return null. So this is another edge case. Now after you have done with this, right, if this is true, if this is not true, then what you have to do is simply what we have discussed, take the second node to the nth node from the starting. So this while loop is there to take the second node um, to the nth node from the starting. Then we are taking this m. All right, we are taking this m, and we are taking this head. So first, inside of m, what we are doing is we are calculating the length of the linked list. Okay, we are calculating the length of the linked list, and then what we are doing is, here we are having this particular loop, right? Now you are checking that if second is not equal to null, store the previous, and then move first and second by one node each, and also do m plus plus, right? Then check if this n is equal to m. That means the nth node is actually the first node, right? That is the head node. So that means you have to make head equal to head next and simply return head, right? You have to remove the head node. If you don't have to remove the head node, we already discussed, take the previous next and point it to first of next. So your first node will definitely be deleted. So this is the whole logic and the approach to solve this particular problem.